Convert bytes to a string in Python 3 Introduction. In Python 3, data can exist in two closely related forms: bytes, raw binary data; str, human-readable text. Example: data equals b, hello. This is a bytes object, not a string. A very common question is, how do I convert bytes to a string in Python 3? This topic explains what bytes are, what strings are, how decoding works, encoding versus decoding, common encodings, UTF-8, real-world usage, common mistakes, best practices. This is a fundamental Python data handling concept. What are bytes? Bytes represent raw binary data. Example: hello. Each character is stored as a colon. Check numeric byte values. What is a string? A string is human-readable text. Example: hello. Key difference, type meaning. Bytes, raw binary data, str, readable text. How to convert bytes, mean string. Python uses decode. Basic example: data equals b, hello. Text equals data.decode. Print text. Output: hello. How.decode works: bytes binary data, decode using encoding, string, text. Most common encoding, UTF-8. Always specify encoding for safety. Data equals b, hello. Text equals data.decode, UTF-8. Print text. Why UTF-8? X supports all languages. Standard for web. Default in Python. Example with non-English text. Data equals konnichiwa. Encode UTF-8. Text equals data.decode. Open parenthesis, quote, UTF-8, close quote, right parenthesis. Print text. Output: konnichiwa. What happens internally? Bytes means UTF-8, decoder means Unicode string. Encoding versus decoding, operation direction. Encode string means bytes. Decode bytes means string. Example of encoding plus decoding: text equals hello. Data is text.encode UTF-8. Original equals data, decode, UTF-8. Print original. Real-world example: file reading with open file.text, RB as f. Data equals f.read. Text equals data, decode, UTF-8. Real-world example: API response, import requests. Response equals requests.get, https.example.com. Text equals response.content decode, UTF-8. Common encodings, encoding usage, UTF-8, default, recommended. ASCII, limited characters. Latin 1, legacy systems, handling errors in decoding. Sometimes bytes are corrupted. Data decode, UTF-8, errors ignore, error options. Mode behavior, strict raises error, ignore skips invalid bytes, replace replaces with. Example with error handling: text equals data decode, UTF-8, errors replace. Common beginner mistakes: 1. Forgetting to decode, print b hello. Outputs bytes, not string. 2. Using wrong encoding, data.decode, ASCII, may fail for Unicode text. 3. Confusing encode versus decode operation, wrong direction. Encode string means bytes, decode bytes means string. 4. Assuming bytes are readable text. Bytes are not directly human readable. Performance considerations: check, decoding is fast. Check, UTF-8 is highly optimized. Next, repeated encode decode should be avoided. Real-world use cases: COC, file reading, network communication, APIs, encryption systems, database binary fields. Example: logging system, log entry equals b, error, failed. Message equals log entry decode, UTF-8. Example: socket communication data equals socket.rexiv 1024. Message equals data decode, UTF-8. Best practices: check, always specify encoding. Use UTF-8 by default. Handle decoding errors safely. Avoid unnecessary conversions. Keep data in correct format throughout pipeline. Simple definition bytes. Raw binary representation of data. Simple definition string. Human readable text in Python. Simple definition decode. Converting bytes into a string using a character encoding. Final summary. To convert bytes to a string in Python 3, use .decode data equals b hello. Text equals data.decode, open parenthesis, quote, UTF-8, quote, close parenthesis. Print text. Output, hello. Key idea. In Python 3, you convert bytes to strings using .decode with UTF-8 as the standard encoding.